What's going on, everyone? Steven here with TechMaker. In the last episode, we worked on running our smart contracts against the testnet, the Rinkeby testnet. And we did that specifically because I wanted to do this episode, which is going to set up a Chainlink VRF element in our contract. And what that means is we're going to interact with the Chainlink network to get a verifiable random number. And what exactly does VRF stands for exactly? Let's look that up really quick. Chainlink VRF, verifiable random function. So basically what we're going to do is just use this contract to generate a random number. Now, the reason I want to do this is because this getting randomness in programming is an important concept. There's a lot of other videos that go into the why behind Chainlink and Chainlink VRF and all this kind of stuff. But I actually have not done this exact thing before, and I'm working on a bigger series. I'm mapping it out right now that we're going to do. We're going to build an NFT game of some kind. I'm still working out the details, but there needs to be an element of randomness in the game. And so I thought, I wanted to make a few kind of smart contract videos, just kind of prepping for all of that. And so that's where we're at right now. So what we're going to do, first time I've ever done this, I'm just going to go through with you setting up VRF inside of our token that we made over the last couple of videos. And basically we'll use random numbers to do some kind of funny things. So with all that said, let's just kind of go ahead and get started, I think. So first of all, over here on the docs.chain.link site, kind of goes through the details of exactly what we need to do. Basically, we have a function called request randomness, which will call out to Chainlink, and then fulfill randomness, which is basically a callback. And so if we look down here at the code, you can see we have this constructor, which sets up this VRF consumer base. VRF consumer base is something that's being pulled in from some libraries that Chainlink has actually made. So we'll need to import these libraries also. And then we'll need to say, okay, our thing is ERC20 and it's VRF consumer base. We won't set up the same stuff here, I don't think. We might have the fee, because that's an important point. And let's see what else. Get random number is, well, what are we doing here? So it looks like we can call get random number as a function on this contract. So it's a little bit just like a generic function. It's public, so people can call it. You give it a seed, which is an integer, uint256. So you give it a seed, and then it uses that seed somehow on the back end to actually help generate the random number. So we have to give it. Then we call request randomness against the VRF consumer base. We pass in the key hash, which I think is something specific to the network, so we'll have to look that up. I don't know what this is. I think what do all these have to do here? This is Coven, so we need to find these addresses and this key hash for Rinkeby, since that's what we're running on. So basically what happens is we request randomness, and that just hands things over to Chainlink. And then down here, you have to write this fulfill randomness function in your contract, and it's got to have this internal override status. I think the internal is basically saying this can only be called within the contract itself, and override, I think, means we're overriding from a parent class, which would be this VRF consumer base, something like that. So with that said, let's see what we need to do to actually get this going. And again, I haven't done this before exactly, so we'll see what happens. So I think that basically we need to start with this npm install Chainlink contracts, which I've found by just searching for Chainlink npm library or whatever. So we'll come back over to our terminal here, and I'm just going to paste that in and run it. And again, I'm going to pause the video because this may take a second. Okay, so it looks like that went ahead and installed everything. We got a few warnings, but as I said earlier, I'm gonna basically just ignore that for now. So our node modules now should have Chainlink here, and we have source. V0.8 is probably what we want. What's in here? Vendor, dev, VRF, consumer base. So I think that's what we're looking at. And I believe these source things probably have to do with the different Solidity compilers. So we're using 0.8.0, so, or 0.4 maybe. So that's one we're going to want. So let's go back over to the example that Chainlink provided, and we'll copy this and then just like modify it because it's not going to be exactly right. So over in our Zazzle token, right below our import Open Zeppelin, let's paste that. And again, you know, when you're reading through the docs, like especially in crypto, for some reason, like documentation lags behind. I think everybody's so busy that a lot of times this stuff just doesn't get updated. So you can look here and see that this, if we look in 06, well, actually in 06, it looks like they do have these contracts out here. So that should actually work if you're on the 06 level. But if we open up 08, we have to go change the path a little bit. So it'll be 0.8/dev/VRF consumer base. And you can see actually for a second, I really like how in VS Code, I don't know exactly what I set up, but you know, one of the Solidity things I set up, I guess, is just highlighting all these problems, which is really nice. So, so now we should be fine. Like it should go away. Okay, so if we save that, pretty cool. So what we can do is on our ERC20 token, we can actually do VRF consumer base. And this is going to throw an error saying it should be marked as abstract, which I'm learning the more I play around with Solidity that basically means you're inheriting from a parent, but you're not actually implementing the thing you're supposed to implement at this point. That's what I think I'm understanding. So what it's wanting us to do here is write this fulfill randomness function. So I'm going to copy this and paste there. And so we don't have like a random result thing. In actual fact, if we just save, well, it may still, what was I going to say? Should be marked as abstract. So we could just say uint 256 here. Well, what the heck? Random result. I'm just trying to get the warnings to go away right now, basically. So maybe, am I still missing something else? So we're doing this thing with the VRF consumer-based constructor. Let me copy that. Am I able to do this with the constructor like this? I don't know if I can do like multiple inheritance this way. Let me look at this really quick. I don't know if that's possible. What is that saying? State mutability. That seems to not explode, weirdly enough. Okay. So what I want to do, I'm just thinking. So what I need to do actually is I guess I can hard code this, but I don't really want to hard code this. Maybe what I actually can do is say address, and what is that called over here? So we've got the VRF coordinator. So we'll say VRF coordinator, and then we'll have address, because you'll see why I'm doing this in a minute. I don't want to, and they actually say this back over in here somewhere. This is an example which uses hard-coded values for clarity. Don't do this in production. So basically, one of the things they're saying here is like you should be passing these coordinator things in, and that's because if we're running this on different networks, like if we're testing, we don't want to mess up and pass in the wrong address. So we need the VRF coordinator, and I did VFR. Let me fix that really quick. So VRF coordinator, and then the other thing is the link token address. Is that what that is? Yeah, the link token address. So we'll do link token, just like that, actually. And then in our VRF coordinator, first of all, let me see if I can make this look a little bit better. So like that maybe, and then that. And then for this, you know, I had that those comments right there. I was sitting here wondering what those were, and it was right in front of my face. So VRF coordinator, and then link token. Like so, I think. Am I missing anything here? So that's not actually giving me any errors, and I think that makes sense. I mean, if I'm able to do, I'm coming from personally a background. I did a lot more stuff with Ruby, which doesn't have multiple inheritance. So the syntax is strange to me, but that seems to make sense. So if we go, and you see now we have this yellow line down here. So first of all, this is just a warning. So I'm not particularly worried about it because we're not going to do, this is going to all change. This is just a placeholder to make sure all this is happy. So what we can do is actually come over here and run just truffle compile as a sanity check just to make sure that we didn't do anything totally wrong, but typically the editor actually flags it if you're going to have a real problem. So we've got compiled successfully, so on and so forth. So, okay, so now in our deploy contract script, first of all, this is going to be broken now. And that's because this, when we run deploy, this is going to, so we take this first object, so Zazzle, and then we run the constructor. And when I say we, what I really mean is truffle runs the constructor. So it takes the first argument and then calls the constructor with everything else after. And as you can see, now we have three things. We have the supply, which we're already giving it. And then we have this VRF coordinator and a link token. And let's go ahead and go find those. So if we go back over here and we just search for Chainlink VRF RinkB addresses. Let's see if this pulls up something here. Let's see. Chainlink token. So we can find the Chainlink token. Maybe let's check the docs here. Polygon, mainnet. Oh, this is everything we need. Okay, so basically this is all the different networks, what the different things are. So we got the link token right there, which we can pass in. It's actually the second argument for us. So, but we'll just paste that there. And then the VRF coordinator is that. And then you can also see that we need that key hash and we also need a fee. So I'm going to go ahead and pass in all of those things. So we'll say, what would that be? Bytes 32 key hash. And then, what's the other thing? So what we want to do is look at so we have a fee of 0.1 link. So that's actually going to be 1 times 10 to the 17. So actually, you know, my method here of doing this isn't great necessarily. Let's just pass in a uint 256 fee for the moment. We'll have to sort that out in a minute. But what we're going to do is we'll specify at the top, we'll say bytes 32 key hash like that. And then so down here, we'll say first and foremost, let me align this stuff better. Okay, so we'll just say key hash equals key hash. So this gives us the flexibility to run this on different networks. That's the key idea here. We'll say fee equals fee, and that means we need to have a uint 256 up here that's defined. So now these things are set for the contract in the constructor. So if we go back over to our deploy script, so now we need to add that hash, the key hash, and then we also need to add the fee. And what I'm thinking to do, first of all, let's just do this. let's just pass in the number 1 for now, and we'll come back to that in a second. First, let's just check that our test still pass. And I just realized, we're not doing this in a very test-driven way right now at all, which is okay. I guess we could call this like a spike, as they call it, because I've never done this, so I'm just kind of seeing how it works. So that's kind of the deal. I think we'll, first of all, and also I wouldn't know the best approach off the top of my head to test this kind of thing, but that is something I want to look at. So error while migrating, number of parameters for undefined. Got 5, expected 3. Okay, so did I not save this maybe? Is that possible? What do my tests look like here? Zazzle deployed. That should, maybe I didn't save it. Let's just run it again and see, but otherwise I may have a small issue here. Yeah, it said, you could see that here. You could see everything's up to date, nothing to compile. I hadn't saved it, otherwise it would not have said that. Okay, so we're getting a bunch of warnings about unused stuff, but effectively our stuff is still green. So that means we haven't, at this point, we haven't broken that functionality yet, even though we've added a bunch of new lines of code, which goes against what I said earlier in one of the other videos. Like, we should be writing tests first, theoretically, if we're following TDD, but obviously we're not right now. So what I want to look at now is how can we switch this? Because I kind of had this idea of converting here so we could just write 1 million on the other side. But I'm thinking like the link token needs to be passed in sort of a human readable way, and it's like a fraction, and I don't like the way I'm going to have to do that. So what I'm going to do, or try to do, is pass the supply in just straight up, as well as the fee. And then what I'm going to do over here is, instead of saying like this, what I'm going to do is say web3. Let's actually pull this out a little bit. Let's say let supply equal web3 utils dot to way, and then we'll do 1 million and then ether like that, and then we'll pass in the supply. And I'm gonna go ahead and run the tests again and see if they pass, because I want to make sure that like that 1 million is still getting translated the right way, because now we're passing in a very different number, and obviously that's the wrong thing. So let's go double check one thing really quick. Let's go back to the code and make sure we saved this, because what was the last thing we did in here? So we could have just save it and run it again and make sure that we didn't accidentally leave that decimal multiplication on there, because that would cause the problem we're seeing. Okay, that was it. We just didn't save. I got to get better at saving, apparently. So it looks like that works. So basically we're saying take 1 million and convert it into way from, like, imagine the base unit's ether. It's sort of like saying, okay, I've got $100. Give me back the number of pennies that would be, right? But in 18 decimals, so it's a pretty big number. So what I'm going to do is say let fee equal web3 dot utils dot to way, and then I'm going to say 0.1 ether. And then we'll pass that in here. Okay, so that's basically all of the setup. So what we need to do next, we got a few things we need to do. We actually need to get link tokens and give them to this contract, because we're going to have to spend link every time we call out. So let's look back over here at the code. So basically what I did there by that web3 to whatever is like we're doing this multiplication but just outside the contract, and we're passing it in because, as it says here, it varies by network. But anyway, so what we're going to do is we're going to request randomness. We have to give it the fee So you have to have a link balance on this actual contract. And if you think about it, it makes sense because basically what we're doing is we're calling out to Chainlink, which is off chain. Like the calculation for this random number is happening off chain. And then they're calling back into our smart contract with this fulfill randomness deal. And this is going to cost them gas in Ether to execute this function. So we're giving them a fee to basically cover that, and there's more to it than that, but that's part of the idea. Yeah, and so we've basically got to do this request randomness thing somewhere. So what I'm thinking I want to do is, and I'm actually going to cut the video here and make another one in just a little bit to kind of finish this up. But what I think I'm going to do is, first of all, we need to get some Chainlink, Rinkeby Chainlink into our contract. So that's something we're going to have to do. And then we're also going to have to build out the code a little bit more, because right now we don't have anything that's actually triggering the randomness. So what I think I'm going to do is actually override transfer. So we'll have like a transfer function. And basically what it's going to do is it's going to override the transfer that's in the ERC20 contract and call out to randomness, and then this fulfill randomness is actually going to complete the transfer but send the other person like a random amount of your entire account balance. So it's a really funny token. That's kind of the idea. It's goofy. So that being said, as always, thanks for watching. If you made it to this point, if you like this video, be sure to subscribe to the channel and hit the like button. Also hit the bell button so you get all the notifications when we put out new content. But yeah, I'll talk to you over in the next part, which should be coming out probably like right after this. So anyway, talk to you later.